Ozone layer, the Earth's sunscreen. Part 1 of 2. Ozone. The word ozone is derived from the Greek word ozion, meaning to smell. Ozone has a pungent odor that allows it to be detected even at very low amounts. Each ozone molecule contains 3 atoms of oxygen and is denoted chemically as O3. Ozone is a highly reactive pale blue gas that is naturally present in our atmosphere. It occurs naturally in small, trace amounts in the stratosphere. In the troposphere, ozone is formed by a different set of chemical reactions that involve naturally occurring gases as well as those from sources of air pollution. Ozone production. Ozone in the stratosphere is formed naturally by chemical reactions involving solar ultraviolet radiation and oxygen molecules, which make up about 21% of the atmosphere. First, solar UV radiation breaks apart one oxygen molecule to produce 2 oxygen atoms. Next, each of these highly reactive oxygen atoms combines with an oxygen molecule to produce an ozone molecule. These reactions occur continually whenever solar UV radiation is present in the stratosphere. As a result, the largest ozone production occurs in the tropical stratosphere. Ozone location. Ozone is found primarily in 2 regions of the atmosphere. About 10% of Earth's ozone is in the troposphere, which extends from the surface to about 10 to 15 kilometers, 6 to 9 miles, altitude. About 90% of Earth's ozone resides in the stratosphere, the region of the atmosphere between the top of the troposphere and about 50 kilometers, 31 miles, altitude. The part of the stratosphere with the highest amount of ozone is commonly referred to as the ozone layer. Ozone in the atmosphere isn't all packed into a single layer at a certain altitude above the Earth's surface, it's dispersed. Even the stratospheric ozone known as the ozone layer is not a single layer of pure ozone. It is simply a region where ozone is more common than it is at other altitudes. Measurement. Ozone is measured throughout the atmosphere with instruments on the ground, aircraft, high-altitude balloons, and satellites. Some instruments measure ozone locally in sampled air and others measure ozone remotely a considerable distance away from the instrument. Instruments use optical techniques with either the sun, direct, reflected, or scattered radiation, or lasers, green lines, as light sources, detect the thermal emissions from ozone and other atmospheric molecules, or use chemical reactions that are unique to ozone song. At many locations over the globe, regular measurements are made to monitor ozone amounts and their variations over time. Dobson Unit. The Dobson Unit, DU, is a unit of measurement of the amount of a total ozone gas in a vertical column through the Earth's atmosphere. It is defined as the thickness of that layer of pure gas which would be formed by the total column amount at standard conditions for temperature and pressure. The Dobson unit is a way to describe how much ozone there would be in the column if it were all squeezed into a single layer. If you were to take all the ozone in a column of air stretching from the surface of the Earth to space, and bring all that ozone to standard temperature, 0 degrees Celsius, and pressure, 1 atmosphere, the column would be about 0.3 centimeters thick. Thus, the total ozone would be 0.3 atmosphere centimeter. To make the units easier to work with, the Dobson unit is defined to be 0.001 atmosphere centimeter. Our 0.3 atmosphere centimeter would be 300 Dobson units. Typical values vary between 200 and 500 Dobson units over the globe, with a global average abundance of about 300 Dobson units. The Dobson Unit is named after Gordon Dobson, a researcher at the University of Oxford who in the 1920s built the first instrument to measure total ozone from the ground. The instrument, called the Dobson Ozone Spectrophotometer. The Dobson Ozone Spectrophotometer, also known as Dobson meter, Dobson spectrometer, or just Dobson, is one of the earliest instruments used to measure atmospheric ozone. Ozone and the atmosphere. If all of the air in a vertical column that extends from the ground up to space were collected and squeezed together at a temperature of 0 degrees Celsius and a pressure of 1 atmosphere, just like with ozone, that column would be 8 kilometers thick. Compare that to the 0.3 centimeters, and you will realize how tenuous is the Earth's ozone layer.